Okay, so I'm going to show you how to calculate a one-way ANOVA. So one-way ANOVA essentially means we only have one factor. In this case, it is plant height. And the difference between an ANOVA and the t-test is t-test only allows you to compare two groups. So like a control one treatment. But the ANOVA allows you to compare many, many more. So to calculate a one-way, we go to our data tab and data analysis, and then it's all in alphabetical order. So we're looking for ANOVA single factor. I'm going to select that, and then we input our range. So we just highlight all of our data, and then it asks, is it grouped by columns or rows? Well, in this case, every single column has on the sheet. I'm going to go OK. So what the ANOVA does is basically it looks at the variance between the four groups compared to within a group, so say within the control, within treatment 1, within treatment 2, to come up with whether it's significant or not, and presents us with a p-value. So because it is exponential to the minus, that means that it's a very, very small number. There's lots of decimal points. So in this case, you would report it as p is less than 0.001. And what value are we always looking for? I'm just going to put that below. We're always looking for p is less than 0.05. So in this case, our value is smaller than 0.05, which means that there is a significant difference between the different treatments in terms of plant height. What you can then do, if you're very keen, is try and find out what groups vary. Where is the significant difference coming from? So say, for example, imagine if T1 and T2 were the same biostimulant, but one was in a higher concentration. It might be valuable to run an independent t-test on these two columns, because it will tell you if there is no significant difference, then you can use the stimulant at the lower dosing rate, which will then save costs. So that's just one way you can explore it further.